Hello, and welcome to the introduction into critical raw materials for emerging technologies. What are critical raw materials and why are they important? The criticality of a material or metal is not a physical property like its melting point. We call a metal critical when we want to draw attention to the fact that we need to secure its supply. Metals need attention when they are highly important for the country, the territory, or the company in question, and when there is a risk that supply could be disrupted, which we call supply risk. All approaches to define critical materials combine at least these two dimensions. The importance and the supply risk of a metal can depend on numerous factors, such as how much the raw material contributes to national income, how the available reserves are distributed, how difficult it is to substitute the material, the possibilities to recycle it, and so on. You will learn more about these factors in the upcoming modules. In the following, we are going to look at a few key issues involving critical raw materials and their importance for emerging and clean technologies. The world, as far as our knowledge goes, is based on a finite number of elements. Everything we know is made up of these elements, and if one is not available, it cannot be replaced by another element. Other elements might be able to serve similar uses in some cases, but they are not exactly the same. The elements of the periodic table are unequally distributed in the Earth's crust. As you can see in this figure, 3/4 of this crust consists of oxygen and silicon, and the very large majority of elements together makes less than 1% of the overall content of the Earth's crust. In the last centuries and decades, mankind has rapidly increased the number of elements they use. For example, for energy production, for thousands of years, our supply of energy was based on stone, wood, and coal. With the industrialization around 1800 in Western Europe, a broader variety of metals became important. One example that most people are familiar with is tungsten, which was used for filaments in light bulbs because of its high melting point. When more complex machines evolved with the invention of the production line around 1900, these also required more complex materials, and thus more different raw materials. Today, there is almost no element left which is not used in some industrial application. And these elements are not put together in a simple way. A single mobile phone consists of 500 different components, such as the display, the case, the circuit board, the battery, and so on. And it is composed of 60 different elements. These are 3/4 of the stable elements of the periodic table. Many of them are not only used in one, but in many of the different components. That means the metals we are talking about are frequently mixed with many other metals, and their amount in a product, and especially in a single component, can be very small. In summary, critical raw materials have some specific characteristics. They are relatively rare in the Earth's crust. They are increasingly needed for leisure technology, but maybe even more important for new and clean technologies such as energy production. And they are often mixed with other materials. All of this poses specific challenges that we will further explore during the course.